Hey guys, welcome to the worked answers for the 2017 Level 2 Calculus paper. Let's get into it. So question 1a, it says a function f is given by f of x equals x to the power of 5 plus 3x squared minus 7x plus 2. Find the gradient of the graph of the function at the point where x equals 1. So we've got this function here, f of x equals x to the power of 5 plus 3x squared minus 7x plus 2, and they're talking about finding the gradient of the graph. So let's go ahead and differentiate. So f dash of x gives us the gradient function. So deriving this, we've got 5x to the power of 4 plus 6x minus 7. And they're asking for the gradient at the point where x equals 1. So we can say f dash of 1. So we substitute in 1 wherever x appears in our equation. So 5 times 1 to the power of 4 plus 6 times 1 and minus 7. So what have we got? 5 plus 6 minus 7, so 11 minus 7, that equals to 4 here. Okay, derivative and gradient found. This gets you an achieved grade. Okay, question 1b, it says find the equation of the tangent to the graph of the function f of x equals 6 plus 14 x minus 2x cubed at the point 218 on the graph. So we've got f of x, and that equals 6 plus 14x minus 2x cubed. And the question also talks about a tangent. So a tangent is a straight line. Its equation will be y equals mx plus c. And they're asking us to find the equation of this tangent. The first thing we can do is find its gradient. Okay, because if we've got a cubic here, and actually it's a negative cubic, minus 2x cubed. Let me do that again like that, right? And we have a tangent, and a tangent touches the graph at only one point. So like that, for example, touches the graph here. If we find the gradient of the cubic at that point, then by definition, we also have the gradient of the tangent. So we are going to say f dash of x, and that equals 14 minus 6x squared. And then we want the gradient at the point 218, right? So f dash of 2. So gradient at x equals 2. 14 minus 6 times 2 squared. That is 14 minus 6 times 4 is 24. So 14 minus 24. And that equals minus 10. And so we can say y equals minus 10x plus c. Okay, we're not done. We need to find the value of c, this constant here. And to do that, we take a point where we know the tangent passes through it. Okay, and we've got this point 218. So a coordinate is written in the form x, comma y. And we've got 218 as a point that the tangent passes through. So we can actually say 18 equals minus 10 times 2 plus c. Rearranging to solve for c, we've got 18 equals minus 20 plus c, so it becomes 18 plus 20, I believe. So 18 plus 20 is 38 equals c. And so our final equation of the tangent is y equals minus 10x plus 38 here. Okay, equation correct. That gets you a merit grade. You achieved derivative and gradient found. So we found our gradient was minus 10. So the step here gets you an achieved. Okay. Question 1c. The movement of an object is recorded from the time it passes a fixed point. Okay, after t seconds, it has a speed v meters per second, which can be modeled by the function v of t equals 0.5t squared minus 2t plus 1. And it says use calculus to find how long it takes to reach an acceleration of 2.8 meters per second. So it's a kinematics question, I think it's called. Obviously SVA, right? SVA, distance, velocity and acceleration. And if you want to go from velocity to acceleration, for example, you derive. Same for distance to velocity, and going back up, you integrate. Okay, anti-differentiation. Okay, so what are we doing here? We've got this velocity function, v of t equals 0.5 t squared minus 2t plus 1. Okay, and they want us to find the basically acceleration, how long it takes to reach an acceleration of 2.8. So our acceleration function, a of t, is going to be the derivative of the velocity function. So it becomes t minus 2, I believe. And if they want us to work out the time, we can set this equal to 2.8, because that's the velocity that we're working with. And I think here we can actually just solve for t. So t equals 2.8 plus 2, so equals 4.8. Okay, correctly finding t here, that gets you a merit grade. And you achieve differentiating correctly, so the previous step up here gets you an achieved. Pretty straightforward. Question 1d, a tangent to the graph of the function f of x equals 3x squared minus 4x has a gradient of 2 and passes through the point 5a, where a is a constant. Find the value of a. Okay, so we've got this function, f of x equals 3x squared minus 4x. And now, what is that? It's a positive parabola, and it says a tangent to the graph has a gradient of 2, so somewhere on, let's say, the positive side of the graph, so along here, right? The tangent, y equals mx plus c, is actually y equals 2x plus c, because its gradient is 2. Okay, now we know it passes through the point 5a. That's not saying that this point in here is 5a. It just says the tangent happens to pass through the point 5a. And so I think what we want to do is find this point in here, where the tangent touches our graph. So we can take the derived function of the of our parabola, so f dash of x equals 6x minus 4, and at the point where the gradient is 2, we can set the gradient function equal to 2. Okay, solving for x, 6x equals 6, and so x equals 1 here. And so we know the x value of this coordinate is 1, and so we want to find y. So we can just go f of 1 here. F of 1 equals, when we bring this around, So 3 times 1 squared minus 4 times 1. This is finding the y coordinate, right? So you've got 3 minus 4. That equals -1. So just highlighting this in blue. Now we can substitute that in for y, okay? So the coordinates here is 1, -1. Now how does that help us? Well, if we know we have a function like this, right? Not a function, a tangent. This is our tangent. If it passes through 1, -1, and it also passes through 5a, and we know it has a gradient of 2, we can actually use basically the calculation for the gradient and solve for a. So what is our gradient? So how much room have we got here? Okay, let's just do it the bottom here. So we know a gradient is equal to rise over run, right? So change in y over change in x. And so in this case, what does that equal? Let's have our top equation be x1 and y1, and this is x2, y2. So it's y2 minus y1. So a minus 1 over x2 minus x1, so 5 minus 1. And actually, because we know that the gradient here is 2, we can set this equal to 2. So solving for a, we've got a plus 1. Sort of running out of room here. Let's say this 2 equals a plus 1 over 4, right? And so 8 equals a plus 1. We've taken our 4 to the left-hand side, and solving for a, we've got a equals 8 minus 1, so a equals 7 here. Okay, so expression for gradient found and value of a correct, that actually gets you an excellence grade here. So first excellence of the paper. And your merit correct y coordinate found for the original function. I think that's referring to our x equals 1, y equals -1 work. So just tidy this up. This is 3 minus 4. And in here gets your merit. And your achieved derivative equals 2, and the x coordinate calculated for the original function. So obviously we said the derivative equals 2, and we solve for x, so up here gets you an achieved. Sweet. Question 1e, the function f of x equals x cubed plus ax squared plus bx plus 2 has turning points when x equals to -1 and x equals -1 and x equals 3. Okay, so we've got this function f of x equals x cubed plus ax squared plus bx plus 2, and they're talking about turning points. Now what is a turning point? Well, if we graph this, we've got an x cubed, so it's a positive cubic, so it looks like this. Turning points are also known as stationary points. Okay, I've illustrated them there. Basically, where the gradient changes from, in this case, positive to negative, and then back to positive again. Okay, and so your turning points are these points in here, basically right at the peak and the trough of the graph. Now, what does this mean in terms of calculus? Well, the gradient of the turning point is going to be f dash of x, and that actually equals 0, right? So let's find our gradient function. We've got 3x squared plus 2ax plus b, and that equals 0. So that's sort of our base idea here. And so if we've got turning points at x equals -1 and x equals 3, let's say, okay, we could draw some axes in here, right? Like this. And we could actually bring do that a bit better. We could bring our turning point coordinates down to the axes, and we could say, obviously the small x value is going to be on the left, so -1 and 3, right? We could say f dash of -1 equals 0, and f dash of 3 equals 0. And so we're actually going to be working with this information, and we're going to come out with some simultaneous equations here, and that is how we're going to solve for a and b. Alright, so looking at our f dash of -1 equals 0, we're going to say 3 times -1 squared plus, let's just do this quickly, let's go minus 2a, right, plus b equals 0, and we've got 3, f dash of 3 equals 0, 3 squared is 9, 9 times 3 is 27, so 27 plus 6a plus b. I hope this makes sense. So we've just skipped a few steps in terms of substituting the 3 and then simplifying, equals 0. And for our first equation, let's just tidy this up straight away. -1 squared is +1, so it's just +3. Okay, so we've got our two equations. We are going to solve simultaneously. So let's just bring our second equation, bring it below our first, because we are going to use the elimination method straight away here, just to get rid of our positive b. So we can say 27 plus 6a plus b equals 0. Okay, so you'll see I've sort of aligned the two equations vertically. So you've got your 3 and your 27, you've got your a's and your b's, and they both equal 0. Okay, and so here we've got, hopefully you're familiar with the elimination method. Our b's are positive, and so we are going to subtract the two equations here. So we've got 3 minus 27, that is going to be minus 24, minus 2a minus 6a is minus 8a. Obviously your b's cancel out, right? And this equals 0. Okay. And so here we are going to solve for a. We can say 24 equals 8a. Sorry, that's minus 24. And therefore a equals minus 24 over 8, so it equals minus 3. Okay, so we've got a. Now we need to obviously complete our simultaneous equations and solve for b. We can take any of our equations and solve for b. Let's take, we've got 3 minus 2a plus b is going to be the easiest way of doing it. And so we could say b equals minus 3 plus 2a. And so minus 3 plus 2 times negative 3. So it's minus 3 minus 6. And that equals minus 9. Okay, so b equals minus 9. A and b found. A equals negative 3, b equals minus 9. That gets you a excellence grade here. Okay, your merit x equals to negative 1 and x equals 3 substituted into gradient functions. So you have to do both of them. So merit up here, all this work. And then your achieved is derivative found and equated to 0. So the step here gets you the achieved. Okay. That's us for question 1. Let's move on to question 2. Okay, so question 2a, it says the diagram below shows the graph of the function y equals f of x. Okay, we've got this graph here. And we've been asked to sketch the graph of the gradient function y equals f dash x on the axis below. Both sets of axes have the same scale. Okay, so this is a bit difficult. In the exam, you have obviously a piece of paper in front of you. You're not doing it digitally. But what we're going to do here is basically take note of our turning point and where it crosses the x-axis. So let's use, I guess, red. So this is the x-axis. We bring it all the way down, and this is what you do in the exam. You get your ruler and you draw, and we can even take the turning point, although it might not be. Actually, yeah, it is necessary in at this level. Okay. So bring it all the way down, touching the x-axis. It's going to touch here. Your turning point is in here roughly, and your other root is there. Okay, so if we're sketching the gradient function, I guess the first thing to note is that we've got a negative parabola here. Okay, so we could say y equals minus x squared. Then the derivative of that function is going to be like minus 2x, right? Basically, forget about the 2, but it's going to be a negative straight line, right? So a straight line that slopes downwards like that. Okay? So, I guess the turning point is actually the most important part. At the turning point, so again, we can go up and just emphasize that. So, where are we? In here is your turning point. That is where, basically at that point, we said the gradient is 0, and it's also where it changes from, in this case, a positive to a negative gradient. Remembering that this graph is the graph of f dash of x, okay, the gradient function, and that's what we're sketching here. So, at this point, the gradient was 0, and so we want our straight line to pass through basically this point here, where y equals 0, just to the left of the y-axis, and so our gradient function is going to look like this. We're just going to extend it downwards. It's going to pass through that point. Okay, and actually that's a poor drawing. We'll redo it. Obviously you have your ruler with you in the exam. And I'm just going over it a few times, but yeah, that is our drawing here. Okay, what does the marking schedule say about it? Straight line with a negative gradient, yep. X-intercept between 0 and negative 1, and that's sort of what we've got here. Okay, so this gets you the achieved grade. Okay, moving on now to question 1b, it says the graph of a function f of x equals 2x cubed plus bx squared minus 2 has a turning point when x equals -1. Find the value of b. Okay, so we've sort of done questions like this already. We've got f of x equals 2x cubed plus bx squared minus 2. And if we have a turning point when x equals to -1, then we can say f dash of -1, that is, equals 0, because, again, at the turning point, the gradient is 0. So this is our equation we're going to work with. So I guess the first thing we could do is derive. So we've got 6x squared plus 2 bx. And so we're going to say 6 times -1, so inputting this -1 now. -1 squared plus 2 times -1 times b equals 0. Okay, simplifying, you've got 6 minus 2b equals 0. Okay, solving for b, you've got 6 equals 2b. And so therefore, we can see that b equals 3 here. Okay, so value of b found, that gets you a merit grade. And your achieved derivative found and equated to 0. So I guess the step here would get you an achieved. Okay, question 2c. Use calculus to show that the line y equals 15x minus 12 is a tangent to the graph of the function f of x equals 4x squared minus x plus 4. So we've got this straight line here, y equals 15x minus 12, and we've got a function, f of x, sort of a quadratic function, equals 4x squared minus x plus 4, and they want us to basically prove that the straight line is a tangent. So we could, I guess, just illustrate this again. So you've got a positive parabola. Now our tangent line, or our line y equals 15x plus 12, has a gradient of 15x, so it's a positive gradient. So like that, for example, touches in here where the gradient is 15. Okay, and I think this information around the gradient is actually what we're going to use to prove that our straight line is a tangent. Okay, so we can take the gradient function of our parabola f dash of x, that is going to equal 8x minus 1, and we want to find out the x coordinate when our function's gradient is 15. So we can say this actually equals 15. And so we're going to solve for x, so 8x equals 16, and so x equals 2. So what this tells us is that when x equals 2, our parabola has a gradient of 15. Okay. Now, what is the y-coordinate of this x equals 2 point? Because if we have the coordinates, then we can sort of match it up with our tangent, right? So we can say f of 2 equals, 4 times 2 squared. So this is our original function, not the gradient function. Minus 2 plus 4. You've got 4 times 4 is 16, minus 2 is what is it, 14 plus 4 is 18. So this point here that we're talking about is 2, 18. And we can write this in here, 2, 18. Okay, now all we have to do is check that our tangent passes through the point 2, 18. And what we can do is say, if we've got y equals 15x minus 12, we could, again, check x equals 2, so x equals 2, and check the y coordinate. If it's the same, then we know it's tangential to our parabola, so equals 15 times 2 minus 12, and you can sort of see it coming, 30 minus 12, and that equals 18. Okay, so here, again, the coordinate is 2, 18, and so there must, obviously we're talking about the same point, and so our line y equals 15x minus 12 must be a tangent, right? Okay, so x and y values found on the original curve and also on the given line. We've matched them up, so 2, 18 in both cases. That gets you a merit grade. Derivative found and set equal to 15. That gets you an achieved, and that was up here. This working gets you an achieved. Okay, moving on now to question 2D. It says use calculus to find the value of k if the line y equals 6x plus k is a tangent to the graph of the function f of x equals x squared plus 2x minus 1. F of x equals x squared plus 2x plus 1. Minus 1. Okay. And again, we've got the straight line y equals 6x plus k, and they say, this time they're not sort of asking us to find if it's a tangent, they're telling us it is a tangent, and we've got to find k here. So, I guess the information to extract is again the gradient. So, we've got a positive parabola. We'll draw it over here actually. And if our straight line is a tangent, then its gradient is in here, right? 6, because y equals mx plus c. M is the gradient, so gradient is 6, so positive. So again, let's just say it like that, where the gradient is 6, m equals 6. And so they're asking us to find basically when, and I enjoy sort of writing out these sort of sentences here just to clarify what's going on. When does f dash of x equals 6? That is the key sort of crux to this question, right? So we're going to say f dash of x, that equals 2x plus 2, and we're going to set that equal to 6. So 2x equals 4, and therefore x equals 2. Now, we don't really know if we need it or not, but we could also say, well, if x equals 2 at this point, what is the y coordinate? So we can say f of 2 equals, now what was our original function? X squared plus 2x minus 1. So 2 squared plus 2 times 2 minus 1. That equals 4 plus 4 minus 1, so that is 8 minus 1, so 7. So this coordinate in here is 2, 7, right? And we could even write it up here again, 2, 7. Okay, now how does this help us? Well, if we've got a tangent that passes through the coordinate 2, 7, and what is its equation? Y equals, what was it? 6x plus k. We know it passes through the point 2, 7, and so we can substitute the information. So 2 is your x, 7 is your y, so 7 equals 6 times 2, so it'll be 12 plus k. We'll just scroll down a little bit more here. 7 equals 12 plus k, and so solving for k equals 7 minus 12, and that is going to be minus 5, I believe. So k equals minus 5 here. So value of k calculated, rather, that gets you the excellence grade. Your merit x and y found. So I guess up here, your merit and your achieved derivative found and set equal to 6. So up here gets you your achieved. Sweet. Question 3e now. Use calculus to prove that the graph of the function y equals x cubed times 3 minus x has a local maximum value when x equals 9/4. Justify that the turning point is a local maximum. Interesting. So we've got y equals x cubed times 3 minus x. Okay. So I guess the first thing we could do is get rid of our brackets and just expand. So y equals 3x cubed minus x to the power of 4, right? Okay, and they're talking about this local maximum when x equals 9/4. Again, what is a maximum? Well, that is like your turning points, right? And it mentions it here. Justify that the turning point is a local maximum at turning points, at maximum and minimums, f dash of x, or in this case it's going to be, they've given it to us in Leibniz notation, so dy over dx, that equals 0. So let's differentiate our function here. So we can say f dash of x equals 9x squared minus 4x cubed, and we're going to set that equal to 0, and we're going to find the x coordinates, and hopefully, well, actually we know one of them is x equals 9/4. We're going to find the other, and we're going to try to justify that basically the maximum and minimum, right? Okay, so solving this cubic equation here. Now that looks difficult. Let's use our calculator. So mode number 5 for equation, number, I guess, 4 for cubic. And our a value is, in this case, minus 4, I believe. B value is 9, and C and D are 0. And so x equals, and actually should we mention that y is c and d 0. A cubic is written in the form ax cubed plus bx squared plus cx plus d, right? That's why c and d are 0. Anyways, x equals, according to the calculator, 9/4 and 0. Okay? So they want us to justify that this x equals 9/4 is the maximum. Now, how are we going to go about justifying? Well, actually, our original equation is this x to the power of 4. And that's sort of, like, trying to justify it graphically is sort of outside the scope of what we're doing here with level 2 calculus, I think. Okay, don't quote me on that. But what we are going to use is the second derivative, right? So we're going to say f double dash of x, that equals 18x minus 12x squared. And we're going to substitute our value of x equals 9 over 4, so f double dash 9 over 4 here. Okay, this equals 18 times 9 over 4 minus 12 times 9 over 4, and that is squared. And what does that equal? Definitely we will be just calculating that. So what have we got? Okay, what is it? 18 times 9 over 4. That equals 81 over 2, or 40.5. Just do our calculation in parts. Minus 12 times 9 over 4. Now that fraction is squared. Okay, that gives us 243 over 4, or 60.75. And yeah, it's a negative. 60.75, running out of room here. Okay, and so just simplifying, 40.5 minus 60.75, that equals minus 81 over 4, or 20.25. Okay, and what does this actually tell us? Well, the specific values don't really matter. We're looking for whether the second derivative is positive or negative. And here, the second derivative, minus 20.25, is negative. We can say that. So, second derivative, negative, okay, meaning, and hopefully you have come across this, this means that turning point is a maximum, right? So that's just a rule that I guess you should know. F double dash of x, if it's if it's positive, then it's a minimum, and if it's negative, then it is a maximum. And when it equals 0, I think you start getting into like stationary points, points of inflection, but you're only working with minimum and maximum turning points here. Okay, so that is our justification. And so local maximum justified, that gets you an excellence, and possibly we should say somewhere mention x equals 9 over 4. So what have we got? Meaning turning point, and we'll just say in brackets x equals 9 over 4 as a maximum. Okay, so this gets you an excellence grade, local maximum justified. Your merit cubic equation solved. Now where was that? Cubic equation solved. So in here, your merit, solving for values of x, and derivative found, so up here, gets you an achieved. Sweet, that's us for question 2. Let's move on to question 3 now. So question 3a, it says the gradient graph of a function is given by f dash of x equals 6x squared minus 2x plus 4. The point 13 lies on the graph. Find the equation of the function f of x. So finding the original function here. So we've got f dash of x, the gradient function, that equals 6x squared minus 2x plus 4, and we know a couple things. We know f of 1 equals 3. Okay, that's going to help us find our constant. Now, we want to integrate here or anti-differentiate, so we can say f of x equals, and so hopefully you're familiar with this, we're going to say 6x2 plus 1, not 2 minus 1, 3 over 3 minus 2x squared over 2 plus 4x, and we could even write 4x 1 over 1 plus c. Simplifying this, we've got 2x cubed, our 2's cancel here, so we've got minus x squared and plus 4x plus c, and so this is f of x, or you could write y. And the reason you do that is because now finding c, we're going to substitute in this information for f of 1 equals 3, okay? We are going to say that 3 equals 2 times, and we've got to do this all again, 2 times 1 cubed minus 1 squared plus 4 times 1 plus c, and so we're solving for c. Let's say 3 equals 2 minus 1 plus 4 plus c. 3 equals 5 plus c. And I'm hoping that I haven't made any mistakes, and c equals minus 2. Let me just check. Yep, it does. So you've actually got to obviously write out the full function now. You don't want to miss out on marks for that. So f of x therefore equals, what have we got? 2x cubed minus x squared plus 4x minus 2. Okay, so function correct, that gets you an achieved grade. Sweet. Moving now to question 3b. So one of these diagram questions again. We've got the diagram below shows the graph of the function y equals f of x, f dash of x, okay? And I assume they're going to have us write f of x. Yeah, so the point 0, 0 is on the graph of the function y equals f of x. On the axis below, sketch the graph, sketch the function f of x. Both axes have the same scale. So they want us to sketch f of x. Key thing to remember is point 0, 0 is on the graph y equals f of x, so we have to include that point in here. Okay, but it's the same thing. This time we're going the other way, right? We're going from the gradient to the original function. Okay, we're going to take our red, and we're going to bring everything down. Again, use a ruler in the exam. Okay, and what have we got? It was in here, right? So there, and I guess there. Is that about right? Yeah, okay, yeah, that's good. And so we've got a positive, if f dash of x, so the gradient function, is a positive parabola, so x squared, then the original function is going to be a positive cubic, so let's just say x cubed, okay? It's going to look like that. your turning points are where the gradient function crosses the x-axis, so there and there. Okay, those are your turning points. So our function is going to look like this. What have we got? Positive cubic, so turning points, let's just say here, has to pass through the origin, 0, 0, and a turning point there. So let's just sketch this. We've got, again, positive cubic, it's going to look like that. Turn, come through 0, 0, the origin, and turn again, and goes back up. Okay, what's the criteria for achieved in merit? Maximum and minimum aligned with intercepts gets you your merit, and I think we've done that here. Merit. And you achieved positive cubic shape through the origin. So yeah, just a cubic with the origin gets you an achieved. Let's say for merit, TPs gets you a merit. Okay. Moving on to question 3C. An object can move in either direction on a straight track and has a constant acceleration of -4 centimeters per second. A fixed point P is marked on the track. When a recording of the object's motion begins, the object is 12 centimeters from P, is moving away from P, and has a velocity of 6 centimeters per second. Using calculus, find the speed of the object 5 seconds after its motion began being recorded. So again, just note on the side, SVA, right? SVA. If it has a constant acceleration of -4 centimeters per second, we can say A of t equals -4. Okay. Now, let's integrate to find the velocity function. V of t equals -2t squared. Not t squared, just -2t. And actually, I've done that wrong, haven't I? It's just -4t plus c. Okay, so and now what? We have to find c, right? Yeah, they want us to find the speed of the object 5 seconds after its motion began being recorded. That means we have to find c. So we have to pull out some other information, and it's probably going to come from in here. We could say when the recording of the object's motion begins, we know that the velocity of the object is 6 centimeters, and I'm looking at this third bullet point here. Okay, so we can say v of 0, because time was 0, equals 6 centimeters, and so solving for c here, v of 0 equals -4 times just 0, right? So that's going to cancel, plus c equals 6, not 0, 6. So the 4 cancels, and so c equals 6. Okay, so our velocity function is v of t equals -4t plus 6. And what's the question asking? Speed of the object 5 seconds after its motion began being recorded. So v of 5, because t equals 5, equals -4 times 5 plus 6. And what have we got here? -20 plus 6, and that equals -14. And you might be wondering, well, what's going on here? You've got a speed of -14, and that's all right, because velocity is a vector, and if you've got a negative velocity, that just means it's switched directions. Okay, so velocity found, v equals minus 14, that gets you a merit grade. You achieved anti-differentiated using including the constant of integration. So you just include the constant. You don't have to find c equals 6, I don't think. And so we're going to say your achieved is up here. Okay. Question 3C2. What is the maximum distance of the object from point P? Justify that this is the maximum distance. Okay, so let's just write out what we know. We've got a of t was, I think, minus 4, right? V of t was minus 4t plus 6. And so we can integrate the velocity function to find the distance function, s of t. That is going to be minus 2t squared plus 6t. And again, we've got this plus c. Okay, and we want to, so we need to find this constant. Again, we look back to our information at the start of the question for some help. And we can say, again, when a recording of the object's motion begins, and so at this point, t equals 0, that's helpful to understand. It says it's 12 centimeters from P. So we're going to use that information, 12 centimeters from P. Obviously, we're talking distance, talking in terms of distance. We are going to say that s of t, not s of t, s of 0, right, equals 12. And so, what have we got here? Minus 2 times 0 squared plus 6 times 0, and you almost don't have to write this out every time when you solve for c, but that's right, plus c equals 12, and so our terms cancel and we're left with c equals 12. So your distance function, s of t, is minus 2t squared plus 6t plus 12. Question's asking, what is the maximum distance of the object from the point P? Now, it's sort of including different branches of calculus here, but we've talked a lot in the paper about maximum minimums, and we know at maximum and minimum points that the differentiated function of the original is equal to 0. Okay, because gradient equals 0. And so we're actually going to take the differential of our distance equation, s of t, and we're going to set that equal to 0. And we said right at the start of the paper that if we wanted to differentiate s of t, we would come out with v of t, right? And then the second, like differentiating again, second differential is acceleration, a of t. And so we're going to say v of t, in this case, equals minus 4t plus 6, and we already know that. We worked that out before. Could even highlight it. Okay. And so we're going to set that equal to 0. Okay, because we're talking in maximum, talking about maximum distances. Solve for t here, so let's say 6 equals 4t. Therefore, t equals 3 over 2, or 1.5. Okay, 6 over 4. Same thing. And And so when it is a maximum distance, 1.5 seconds have lapsed. And so we're going to solve S of 1.5. Okay, we're going to solve for the distance here. We're going to find the distance. So we're going to say minus 2 times 1.5 squared plus 6 times 1.5 plus C, not plus C, plus 12. Okay, and what does that equal? And let's just calculate it using our calculator. Minus 2 times, and I'm going to say minus 2 times answer plus 6 times answer plus 12. And now I'm going to say 1.5 is our answer. And we get S equals 18 here. And that's not correct because I forgot to put 1.5 squared, didn't I? So try it again, 1.5, and then S equals not 18, but 16.5. 16.5. Okay, we've got to justify that this is the maximum. And how are we going to do that? You could even say, you could use second derivative, which is funny because second derivative, a of t, the acceleration is, that was a constant, wasn't it? We said that was, minus 4. And so if a of t is minus 4, obviously it's negative, and so that means maximum, right? We discussed that in the earlier question. You could also justify it graphically, so you've got a negative parabola, so it looks like this, and so any turning point for the negative parabola is going to be a maximum, right? Okay, so S equals 16.5. You've confirmed that the distance is a maximum. Reference to graph or second derivative gets you the excellence grade here. Your merit is finding the value of S, so without justification. So let's say in here, S equals 16.5 is a merit, and you achieved equation for S. And we found that first by integrating V of t and then solving for C. So achieved is up here. Okay. Moving on to the last question of the paper. 3D, and it says find the maximum volume of an open box, a box with a base and sides but no lid, okay, that can be made from a rectangular piece of cardboard measuring 20 by 30 centimeters by removing the corner squares and folding along the dotted lines, and that's what they've shown us here. So we've got 20 by 30, obviously no lid, and the squares they're talking about are just highlighting in blue, like in here, right? Okay. It says justify that this is a maximum volume, and I forgot to highlight, obviously we're finding the maximum volume, and they want us to justify that this is the maximum volume. Okay, so what is the volume? Well, volume is, there's a few different ways you could write it. Base times height times like width or length or whatever. You could also write it as area. And so that sort of encompasses base times height times, again, any variable, width. Yeah, let's just say, I don't want to use width. Let's say height again, okay? You see where I'm coming from. Let's establish an expression for the volume. So, and that's actually how we're going to write it. Area times height is the way we're going to go about it. So area of the, not cross-section, but like bird's eye view, right? And then we will multiply by the height. Now, what is the height? Well, the they don't tell us a height, but it is actually going to be just a single variable. Let's say x. And we know that because looking at our squares here that have been cut out, we can say that their length and width is x all the way around. And so this doesn't necessarily tell us a height, but if we set up our equation like this, area is obviously base times height. As we look at our plan, we are going to say 20 minus 2 times x. Okay. Now this might not make sense, but the way I'm sort of attacking the question is not by trying to find the individual like dimensions or area or volume of each part. Obviously you could do that, you could do that, but rather area of the whole shape minus the squares cut out. Okay, so 20 minus 2x multiplied by 30 minus 2x. So that would give our area of the shape, and your height, if you were to fold along the dotted lines, which is what the question says that they do, okay, obviously your height all the way around is going to be x. And that's what we're going to say, multiplied by x. So that is our equation. Let's expand the brackets and then we will differentiate and set equal to 0. So obviously expanding brackets, I'm talking about the FOIL method, so you're multiplying, right? First, outer, inner, and last. We'll deal with our lone x at the end. So we've got 20 times 30 is 600. And what have we got? Minus 40x minus 60x is minus 100x. Plus 4x squared. This is still inside brackets because it's being multiplied by x. And now let's do that. Let's multiply by x. So 600x minus 100x squared plus 4x cubed. Okay, that is our expanded expression for the area. And they're talking about maximum volume, so let's differentiate. Let's say f dash of x equals 600 minus 200, right? 200x plus 12x squared. And we're going to set that equal to 0 because, again, they're talking about maximums. And the gradient at a maximum is 0. Okay, we can solve for x here. We've got a quadratic. Don't bother trying to do it manually. Just use a calculator. So mode number 5 for equation, number 3 this time for quadratic. A value is not 600, but it's 12. B value minus 200. C value is 600. And so x equals 12.74 or 3.92. 3.92. And you might be inclined to look at this and say, well, 12.74 is larger, so it must be the maximum. But that's not true. So how are we going to justify that it's the maximum? You could do second derivative. You could do it graphically. We've got a positive cubic where the maximum and minimum are these turning points here. If we drew some axes on here, okay, we extended it up to the axis like that, you would have the smaller x value as being the maximum. Okay, I hope that makes some sense. So 3.92 x equals 3.92 is going to be our maximum value. Obviously, x equals 12.74 represents the minimum value, okay? You could also double differentiate. If you substituted in x equals 3.92, you'd come out with a negative answer, and that would mean maximum value, okay? I'm not going to do that here. Let's just move forward with x equals 3.92 as being the maximum. And so they want us to find the volume, I believe. We'll just go back up to the question. What is it asking us to do? Yeah, so find the maximum volume and justify. We've already justified, basically. Last thing we need to do is find the actual volume. So we're going to substitute in x equals 3.92 into our original equation. So if we've got v of x equals the function, now what was it, 600 x, what was it, minus 100 x squared, I believe, plus 4x cubed, yeah, that sounds about right, 4x cubed, we can say v of 3.92 equals this whole thing again. I'm going to run out of room. Let's just do it below. 600 times 3.92 minus 100 times 3.92 squared. And yeah, I really am going to run out of room. Plus 4 times 3.92 cubed. Okay, and so we can just calculate this. Um, 600 times 3.92 minus 100 times 3.92 squared plus 4 times 3.92 cubed. That is going to equal 1056. 1056.31, okay, to 2 decimal places. Okay, and that is our correct volume. So confirm that x value is a maximum by reference to graph gradient on either side or second derivative. So that was our justification. But yep, correct volume with justification, that gets you an excellence grade. Your merit differentiated and x values found for turning points and volume found. Okay, so that's doing everything without justifying, which just say merit in here. And you achieved relationship formed and differentiated. So forming the original equation and then differentiating is going to get you an achieved. So the step here gets you an achieved. Okay, and that is it for our paper. Yes, I hope you guys enjoyed. And it's just glitched out on me. Oh yeah, here we are. I hope you guys enjoyed. As ever, any questions, comments, chuck them in the comment section below. And I will see you guys next time. Cheers.